Okay, let's start. Good afternoon to everyone. My name is Rosario VALOTTA, and as you can guess from the talk's title, we are going to discuss some vulnerabilities about browser user interfaces. And more in detail, I will show you how attackers can use a couple of techniques to compromise victim security and also get code execution over victim's machine with just a little bit of social engineering. We are actually talking about making one click or typing one key on your keyboard. So, before diving into technical details, just a few words to better introduce myself. I come from Rome, Italy, where I work in a mobile telecommunication company, so this is my daily job. But in my spare time, which is mostly nighttime, I like practicing web security. I'm active in this field since 2006, more or less. I developed some new attack techniques, proof of concept, spoke at a bunch of conferences. These are some of my previous works. If you want to check them out, you can go on my website. So let's start our discussion talking about social engineered malware. Without any doubt, malware spread is one of the most compelling problems that web security industry has to face nowadays. Malware spread is increasing year over year, and according to some reports provided by Kaspersky Labs, only in 2012, 200,000 malware attacks were spotted every new day. And this led to more than 1.5 billion malware attacks originated from the web. But the most interesting thing is that the majority of these attacks were originated by user-initiated download. So we are not talking about zero-days exploits, drive-by download attacks, and so on. We are actually talking about more than 1 billion users who proactively downloaded some executable on their computers, double-clicked on them, and get infected. So it's quite obvious that when talking about user security, you cannot rely on user consciousness or on user awareness, because the average user is completely unaware of what is doing while surfing the internet. Users need guidance, they need protections from malicious websites, and we can deliver these things by providing trusted and reliable security mechanisms. That's why in the latest years, browser vendors invested a lot of money and efforts into building some new protection technologies and in making the existing one more robust. And so we are talking about protection from memory corruption exploits, for instance, ASLR, DAP/GS, and so on. Protection against web attacks, so XSS filters, anti-framing technologies, and so on. Protection against malware phishing. And so here the technologies' names are safe browsing or smart screen filter. And last but not least, a lot of effort has been posed into building trusted and recognizable browser user interfaces to help users into making aware choices while surfing the internet. And when talking about trusted and recognizable user interfaces, we are actually talking about Chrome. So what is Chrome? Chrome is the component of the browser that includes all the user controls, menus, pop-up dialogues, notification bars, that surrounds the web content itself, providing an interface between the user and the browser. So, to say it with a couple of slides, this is Chrome, this is content. See the difference? One of the most important pieces of the Chrome component are browser security notifications. Because basically, every time you browse to a site, you trust your browser, and you trust to the notifications provided by your browser. Just think about when you are going to browse an SSL-protected website. The notifications that are provided when the certificate is not valid anymore, and so on. So security notifications are a crucial part of browser trust model. They are useful to notify users before making important choice, and so they act as a communication medium between the user and the browser. For that reason, notifications need to be recognizable and trusted. I mean, in a web environment like today, in which every website can be compromised and you cannot trust any virtual identity, your browser is the last line of defense, and you usually trust to notifications provided by your browser. Nowadays, two notification mechanism exists in browsers. Modal notifications and modalless notification. Modal notifications are the classic dialogues that pop ups in the middle of the screen asking you to make one decision. So accept, deny, okay, cancel, yes or no. And they are characterized by a strong visual contrast in order to grab your attention, and they are workflow blocking. So this means that you have first dismiss the dialogue and then continue your navigation. That can be originated by the OS or by the browser, and in some circumstances, they can be very annoying. That's why they suffer from a problem. It's called the default answer problem. I mean, the average user, in order to dismiss this dialogue as quickly as possible, is led to click on the default option. This is a user interface problem that can turn in a really serious security problem. The other kind of notifications are modalless notifications. Modal notifications are designed in order to inform users without interrupting navigation. So they stay in the context of your navigation window, and they are rendered through notification bar like this. They can appear on the top or on the bottom of your browser, depending on the browser and depending on the notification type. What they are used for? They are used for file downloading notification, plugins or ActiveX activations or notification, and also for notifications related to HTML5 APIs. I mean, all those websites that use some HTML5 privileged APIs, for instance, geolocation API, file screen API, file system API, they require your approval before using those APIs. And your approval is required through a notification bar like this. In the latest years, we assisted to a shift from modal to modalless notification system in all major mainstream browsers. You can see that basically Internet Explorer, Chrome, and Firefox shifted to modalless notification systems in all use cases, except from extensions or add-ons installations, while Safari keeps staying on modal notifications only. So modalless notifications are smart, they are not annoying, but they suffer from some problems. First of all, notifications are displayed even if the window is on the background. Second, some keyboard shortcuts are enabled in notification bars. I mean, you can use some keyboard shortcuts in order to interact with the notification bars. And third, notification bars can be navigated using the tab key. So let's go through each of them. Notifications in background windows. Imagine a scenario like the following. You visit an attacker website. The attacker website immediately spawns a pop-up window. The pop-up is taken on the background, so becoming a pop-under. Just a little parenthesis about pop-under. In the latest years, we assisted to a struggle between browser vendors on one side and let's call them hackers on the other side for the control over pop-under. Because pop-under can be very annoying from the user perspective, but very lucrative from hackers' perspective. So every time a new browser version comes out, some APIs that allows controls over pop-under are dismissed. But hackers ever find a new way to control pop-under. So if you browse over GitHub, you can find some project like JS Pop-under that basically enables pop-under in a cross-browser environment. So we are able to open a pop-under. On Windows 7 and on Windows 8, the pop-under is merely unnoticed because basically several browser windows are tabbed very closely in the application taskbar. So especially if you have many windows open, you unnotice it. Then the pop-under starts download, maybe an executable file. All of this hidden from the user view. And when the file download notification is triggered, the pop-under tab doesn't blink to give evidence of a pending notification. So at this point, we have downloaded a file on our computer and no notification is provided for the user. This can be very dangerous. I will show you in a couple of minutes. The second problem is related to keyboard shortcuts. They are available for activating actions on notification bars. So for instance, Internet Explorer allows you to use Alt and R or Alt and S or Alt and O in order to run, save, or open some downloaded file through the notification bar. Moreover, Internet Explorer and Firefox also allow this for HTML5 APIs notifications. For instance, you can press Alt and A or Alt and O in order to grant your position to that website. Of course, navigation window needs to be on focus for these shortcuts to work. The third problem is related to the tab key. Some browsers allow you to use the tab key to navigate through the different buttons, different options provided in a navigation bar. So you can use tab to switch among run, save, cancel, and close button in Internet Explorer. Google Chrome is a little more secure because in the switch process, skips the file opening button, allowing you to skip only between show downloads and close button. So basically, these three issues are the building blocks for the couple of attacks I will show you now. The first attack works on Internet Explorer 9 and 10, both on Windows 7 and on Windows 8. The attack scenario is more or less the one depicted before. So you visit the attacker website, there is the pop-under goes on the background, the pop-under starts the load of an executable file, the modulus notification is triggered, and after the file has been downloaded on your computer, no notification is provided. And now comes the bug. After notification is ready, the pop-under is still on the background, but is the window on focus. And this means that every keyboard input will be directed to the pop-under and not to the foreground window. So if you're able to trick your victim to type some keys, for instance, tab and then R, we can get code execution without any notification or user confirmation. I will show you this in a demo. Let's move to Windows 8. Okay. The proof of concept I taught about is a typing test. You can find a lot of typing tests for free on the web. They will help you to improve your typing skill, typing speed, and so on. So let's take the test and run the first exercise. So a virtual keyboard now will pop up explaining me the exact keys I need to type. Okay? So let's take the test and type ERGO tab REX. Code execution. Okay, so let's see what happened. Okay, I will pop up virtual keyboard in order to show you the exact keys I'm typing. Okay. First of all, look at the Chrome color. The pop-under window is the window on focus. The foreground window is not on focus. So basically, if I press Tab, I will move the focus on the Run button. And if I press R, I'm ready to open my file. Let's close this because this is actually a malware. Okay. So let's go back to the presentation. So in detail, the process in details, I open the first window, the foreground window, not on focus. The pop-under windows is on focus. As soon the download dialog has completed, the keyboard inputs will be directed on the on-focus window. So I first press Tab to move the focus on the Run button, and then press R, or equivalent key. It depends on the OS language. It's R for English, it's E for Italian, it stands for execute, segue. And then profit. Okay, but some of you may think, okay, but it's not so easy to trick your victim to type some strange keys like tab, for instance. But we can do better. On Windows 7, if you open the pop-under using this meta tag, I mean asking your browser to emulate Internet Explorer 7, this will bring the focus on the pop-under directly on the notification bar. And this means that we don't need the tab key to put the focus on the Run button because the focus is already there. So you can trigger code execution by just typing one key. Let's see this in a demo. Okay, The proof of concept is more or less similar to the previous one. We are on Internet Explorer 9. Let's start. In order to proceed with the registration, we need to verify you are not a bot, so I need to enter this CAPTCHA. This CAPTCHA starts with the letter E, which stands for execute, and then I type E, and code execution starts. So basically, the mechanism is the one I showed you before. So there is the pop-under. The focus is already there. So if I press the letter E, code execution. So the second attack I want to show you is works on Windows 8, both on Chrome and both Internet Explorer. It deals with a dynamic window overlay. The attack scenario is similar to the one depicted before. So you visit attacker website. There's the pop-under on the background, starts the load of an executable file, all the stuff related to the notification. And at a given point, the attacker tricks the victim to click on a given link or button on the foreground window. The foreground window can listen through some JavaScript to the mouse movements. This means that as soon as the mouse is hovering on the button, the foreground window can be closed. And if timing is appropriate, there are good chances of victim clicking on the underlying window and not to the foreground. Approaches like this have been already demonstrated by other security researchers. For instance, Michael Zaleski from Google or Colin Jackson. Colin Jackson actually tested this scenario for clickjacking use cases using Amazon Mechanical Turks. And he found out that the success rate of these attacks is more than 90%. So this is quite dangerous. But why we are talking of an attack that is not brand new? Because the danger posed by this attack on Windows 8 is by far greater than on Windows 7. Every time you download a file over your computer using your browser, the operative system adds a file to the file system. It's called a zone information file, and it's basically an alternate data streams that carries information about the security zone the file has been downloaded from. So it can be internet zone, local machine, and so on. On Windows 7, launching an unsigned file downloaded from the web will prompt a confirmation dialog like this, not bypassable. So you cannot activate an executable file by just making one click. But on Windows 8, this type of confirmation dialog has been dismissed, and the smart screen check will be performed instead. I will show you later how to bypass smart screen filter also. So no further dialogues are displayed, and this means code execution by just making one click. Let's see this in action and move to Windows 8. Let's close this. This is Internet Explorer. Okay. Okay, now I visited my beautiful website. I want to open my photo gallery. This is a picture of me and my friends going to holiday in Sicily. This is a very beautiful picture. I want to like it, and then go there, and the foreground window disappears, and the underground windows is shown, and there are good chances of launching the underlying executable file. There are other use cases for attacks like this. For instance, HTML5 privileged API. The proof of concept is the same. You see, I'm listening to the mouse movements, and as soon as I hover the like button, if I'm not careful, I'm granting this website the knowledge of my position. Failed, perfect. The last use case for these attacks is for bypassing anti-framing technologies. All of you know that some websites, for instance, Twitter, Facebook, and Google, implements some anti-framing technologies in order to avoid clickjacking. So the product concept is already the same. There is a beautiful picture of me. I want to like it. And if I'm not careful, I'm adding some new follower on Twitter. So, going back to the slides. This is, okay, you already see this. Okay, are there any limitations for the attack techniques I showed you? Yes, there are a couple of limitations. The first is smart screen filter. The second is user access control. What is smart screen filter? Smart screen filter is part of the technologies that browser vendors developed in order to block access to malicious websites and malicious applications. From a functional point of view, they are made up of client-server technologies. On the server side, there is a cloud reputation-based system that scores the web for finding malicious samples and malicious URLs, categorizes them, assigning each of them a score. And on the server side, on the client side, there is a browser agent. Anytime you download the file, before launching that file, the agent will ask the cloud system if that application of that URL is malware or not. And then it processes the feedbacks from the cloud and enforces some warning and blocking functions on the client side. There are two implementations of these technologies. The first is self-browsing API, and the second is smart screen filter by Microsoft. Safe browsing has been written by Google and is implemented on Safari, on Firefox, and on Google, of course. It supports URL reputation and application reputation only on Chrome. Smart Screen Filter works more or less in the same way, but it's Microsoft proprietary technologies. It has been introduced in Internet Explorer 8, and starting with Internet Explorer 9, also supports application reputation. Starting with Windows 8, Smart Screen technology has been extended system-wide, and this means that a smart screen check will be performed not only when you download a file from your browser, but every time you run a file, an unknown file for the first time, independently from the way you put your file on your PC, maybe CD-ROM, USB key, whatever. The first run, a smart screen check will be performed. So, how smart screen filter works in detail? Basically, after you download the file, you send to the cloud-based server this information, your IP, the URL you downloaded the file from, the file hash, the file name encoded in base64, and the signing certificate if available. All of that encoded in XML format. And what is the output? The output is one of these notification bars. The first, if the check succeeded, this means the application you are trying to download is safe. The second, the application is blacklisted, so the file you are trying to open is malware. And the third, there is a reputation failure. It basically means I'm not sure if the application you have downloaded is a malware or not, but being in doubt, I will disable the run button. If you want to run it, you have to go in action first and then click on run. Okay, but smart screen filter can be bypassed in a given number of ways. First of all, the reputation check algorithm is not 100% reliable. I found a website, it's called MinotaurAnalysis.com. It's a website about malware intelligence provider that provides a huge list of X-tweet. An X-tweet is basically is a shortened URL linking to some malware that is spread all over Twitter. So they are very popular URLs. And I found that almost 20% of the URL provided on that website will bypass smart screen. The second way to bypass smart screen is dealing with time. This kind of systems need some time, some response time in order to catch new malware samples because they need to collect some feedbacks from the users, from malware intelligence providers, and so on. So if you publish your malware in the first publishing days, you have a greater chance of bypass that. The third way is dealing with signed application. When dealing with signed application, smart screen will only look at the certificate reputation and not to the application itself. So this means that from a technical point of view, you can use a perfectly trusted certificate to sign some malware. And if you're able to do this, your malware, your signed malware, will go through smart screen check. But if you are unlucky, if you are not able to get a standard or to steal a standard certificate, you can buy a brand new extended validation certificate that is sold by Symantec and DigiCert, if I remember well. And this kind of certificate will grant an immediately good reputation also to unknown files, also if no prior reputation exists. So you should spend some thousands of euros to get one of these certificates, sign on malware, and you are done. Of course, another way to bypass smart screen agent is dealing with connection. Being a client-server technologist, if you control the internet, you can control smart screen. And so, imagine an attack, a man-in-the-middle scenario, okay? When the attacker can trick the victim to connect to a controlled hotspot, Wi-Fi hotspot. So the victim can connect to the attacker website, download some malware using the techniques that I showed you before, and at that point, the smart screen check is performed, but the attack can hijack every communication to Microsoft. And so what is the result? The result is a new notification bar that complains about the fact that is not able to connect to the smart screen server. But if you notice, the run button is there. And so, if you can trick your victim to type tab and R once again, you are done again. And this time, it's not standard code execution, but it's arbitrary code execution. Let's see that in action. And in order to simulate man-in-the-middle condition, I will connect to a local instance of my proof of concept and shut down my internet connection. So, okay, the proof of concept is the typing test you saw before. Let's take the test. I'm typing the key ERGO tab REX. And I'm able to pop up calc. So let's see what happened. Once again. Let's close these, close this. Okay. Virtual keyboard. Right. Let's resize this a little bit. Okay. You see, on Internet Explorer, on Windows 7, as soon as I type the E key, sorry, something didn't work. As soon as I type the E key, I activated the download. So the smart screen is complaining about the fact it's not able to reach the server. But if I press tab, the focus comes back on execute again. And if I press E once again, code execution. So using this approach, you can run every type of file. Let's go back to our slides. This is the process I showed you before. Okay, the second limitation about this kind of attack is user access control. User access control is a security technology introduced in Windows Vista. And basically, there is a pop-up that is triggered every time administrative privileges are required. So you cannot bypass that, right? But the question is, do you really need administrative privileges to cause serious troubles? So the first version of Carver malware worked completely in the user land. And using user land API was able to do very bad things. For instance, content injection, key logging, out-exec, its user logon, and so on. So at the end of the day, we have no limitations because we can work around smart screen filter And user access control is not a problem. We don't really need administrative privileges. So let's sum up. On Internet Explorer, we can get code execution with one key or one click. And if we are in the man-in-the-middle situation, there is arbitrary code execution. And on Google Chrome, we can get code execution with one click, or install a plugin with one click, or bypass HTML API's confirmation with one click. So some proposals to work around these problems. First of all, notifications on background windows are useless at best. So why don't show the notification after some seconds, since the navigation window has regained the focus? An approach like this has been used by Firefox, for instance, when you try to install a plugin. There is a counter, the counter reached 0, and then you're able to click that button, because only in that moment the button is activated. Then, disable tab key in the notification bar. Just use the mouse. I mean, if you are concerned about accessibility and you want your user to use the keyboard, you can activate some complex keyboard shortcuts in order to limit the chance of being social engineered. Then, some sensitive content, some sensitive notifications, for instance, file downloading, should be ever kept in a static frame of the Chrome component and not bound to the navigation window. I mean, you have downloaded the file on your computer. This is independently from the navigation domain. Okay, this is something related to your browsing experience. And then, some browser-initiated switches between windows of different domain should be always being combined with graphical effects, for instance, fading lightbox, to give user evidence of the fact that we are switching domain. And this switch is not user-initiated, but is browser-initiated. It's JavaScript. So let's jump to conclusions. Browser shift from model to modelless notifications is still not mature. I've demonstrated you at least a couple of techniques that allowed for stealth remote code execution with really minimum user interaction, one key or one click. And final consideration, we have not only to care problems like memory corruption, exploits, or other dangerous techniques, because the easy way is by far the one most exploited in the wild. And I think that browser vendors should really pay greater attention to user interaction model. So I'm over. If you have any question, thank you.
Est-ce qu'il y a des questions? Any question? What would you recommend using? Internet Explorer, Firefox, or Chrome?
Well, in order to avoid this kind of problem, the safer browser is, by the way, Safari, because it's the only one that still stands on model notifications. So being this problem related to modelless notifications, Safari, from this point of view, is the safest browser. Maybe it's not the safest from other points of view.
And links?
Links, I don't know exactly the market share of links.
It's non-existent. Okay. No question? Okay, so thank you very much for your talk.